Okay, I'm gonna hide this. So now we're streaming to the YouTube channel. Let me change the size of this. Next, let's have this available. Hang on. That's fine. Oh, I didn't really want to show all that. I'm totally messing up. Hang on. Let's get rid of this. All of this can go. We don't need that. We don't need that. We don't need that. Okay. We're going to keep this and actually put it here. This is fine for now. We're going to let it be right there. Let me get organized. We can hide this guy. Zoom. So now with Zoom, let me share my screen. Let me think about it. So for Zoom, I don't need this. Let me share the screen. The whole desktop is fine. That's looking right. I'm going to go ahead and make the chat available. Chat is like this one. That's awesome. That's going to be about there. Let's go ahead and pull this up now. Are you slowing down? What's it doing? Okay, that looks good. That looks good. Ooh. Okay. And then let's do one other thing. I'm gonna make this available too. So I think let's do. I wanted to be consistent. So last time we, I think we finished out section 1.3. I don't want to move into 1.4 just yet. So I want to take this time to just kind of go through the homework or answer specific questions. So like if you email me, because I know I've been kind of behind on my emails. So if you email me and if it's like pertinent or pressing or important, now is a good time to ask. Also, I am monitoring the chat, and also be aware that this should be live streaming to my YouTube channel. Let me see. So I decided to go ahead and stream our problem session. I felt like that would just be, I don't know, a little bit better. So that way you can always go back and reference it. So again, if you do have any burning questions, type it into the chat or just unmute yourself. And if there aren't any burning questions, I'm just going to choose questions at random from section 1.3. I think that was the last thing that we did together. Go ahead.
Just a quick thing about did you find out about any access code, being the access code, or?
Yeah, so okay, here's the update on the access code story. Long story short, you have to purchase access to Pearson. So in the past, when I was a professor at Morehouse, it was included in the tuition, but they stopped that program, so that program is no more. So that what that means is that we do have to purchase access to Pearson. So another thing that means is there are a couple of ways to do it. I did have one student successfully get a book new out of the bookstore, and it came with an access code. If you do decide to get a hard copy book, just make sure it comes with an access code. That's the main thing. If you decide to get a hard copy book, make sure it comes with an access code. Else, you can get the access code directly from Pearson. Okay? Hopefully that clears all that up.
Okay? Thank you.
My pleasure. Okay. So I don't know if I did this with this class or not, but what I've noticed that with the chat, like, okay, you see how there are 21 homework questions? Again, if nobody asks for a question specifically, I'm going to ask Google to give me a random number, and we have a little game. So in the chat, I'm going to type, I'm going to open it. I'm going to type open. So, and then tell me what number do you think Google's going to give us, 1 through 21? It's just an intuition game, like to see if our intuition. So I'm going to guess that, I don't know why, for some reason, I'm bobbing with 13. I'm going to say that like Google's going to choose question 13. So it's going to be open for like 10 seconds. Let me see. I'm going to start the timer. 10. So just what number do you think Google's going to choose? You put it in the chat. 5, 4, 3, and then I'm going to type close. So the polls are closed, okay? Just a fun little game. Okay. Hey Google, give me a random number 1 through 21.
Here's a random number. 11.
Oh, Mr. Chavis, he got it. I was close, like I was off by 2, but he got the number correct. So we're gonna work number 11. Now in the future, I might offer some extra credit or something like that, but for right now, we're just having some fun. Okay, we're just having fun. Okay, but he got it right, Jamari Chavis. I feel like I want to have some prizes, some kind of prizes, something easy I could do, or extra credit, but we'll see. All right, find the domain of the function. Have we talked about this? Okay, so with a function like this, right? So let's first start. What kind of symbols does anybody notice about this function? What do you notice? Or if we were to have a restriction on something, what aspect of this formula, this function, do you think might be restricted?
It can't be a negative number because you can't have square root negative.
Right, we cannot take the square root of a negative, right? So that's the first restriction. So in general,
also the fraction.
And the other one is the fraction, right? So in general, for square root, we cannot take the square root of a negative. So this radicand, this x minus 7, it has to be greater than or equal to 0, right? So if we, but because it's in the denominator, that means we have to impose a further restriction or an additional restriction saying that it cannot be equal to 0. So normally we would say x minus 7 is greater than or equal to 0. Let me write it down here. Hang on. So I'm not just being so cerebral. Sure. Okay. So we don't need that. And let's get a copy of the original. Okay. So this is what, homework number 3? Is that right? Are we in the 3rd week already? Is this week? Yeah, week 3, right? Yeah, week 3. Okay. So let me make a quick note here. We'll start off in black, and let's introduce some line paper. So we're in week 3. Is this right? Have we talked about this section already? Okay. So we're in week 3. This comes from section 1.3. I think it's called functions. And we're working question number 11. This is question number 11. It comes from section 1.327. It says, find the domain. And the original function is this thing. Square root x minus 7, 6, right? Okay, let's hop over to the iPad. Boom, just like that. Oh no, I'm gonna put you here, right? Okay, so I'm just taking some notes, right? And I can make a copy of anything that you see me writing on my iPad. I can make a copy available to you. So not only will we have a video recording available, we'll also have a PDF available of what you see me write. So now for the domain of something like this, in general, whenever we have square root, again, we cannot take the square root of negatives. So in general, the radicand being this guy, normally it has to be greater than or equal to 0. But because it's in the denominator, it cannot be equal to 0 because we can't divide by 0. So we had to remove the 0 like this. And then if we solve this inequality, add 7 to both sides, we get x is strictly greater than 7, right? So then, so this should be the domain. And then in interval notation, let's graph this really quickly. Like if we look at the graph, if x is strictly greater than 7, are we talking about the numbers to the left of 7 or the numbers to the right of 7?
To the right.
To the right, right? So we're talking about all the numbers to the right. And then what kind of grouping symbol does that graph get? Does it get a parentheses or a square bracket?
Parentheses.
Why did you say parentheses over a square bracket?
Because it's like able to continue. You're able to continue past that, like past the.
So okay, can somebody explain what's the difference between parentheses and a square bracket? What's the difference between those?
Parentheses is usually for just less than or greater than, whereas brackets are used for less than or equal to.
Yeah,
or
equal to. Yes, yes, that's right, right? So this symbol right here, this is a strictly greater than symbol. So since there's no bar here, we're going to use a parentheses, right? If it were a bar here, like greater than or equal to, we would use a square bracket. So that bar means bracket, B and B, right? Bar means bracket. So parentheses, what parentheses means is, okay, we get really, really close to our number, but we never reach our number. Let me rephrase that. So again, parentheses mean we get really, really, really close to the number, but we don't include the number. A square bracket means we get really, really, really close to the number, but we do include that number, right? That's the difference between parentheses and square bracket. So if this is the graph, now it should be a lot easier to see the interval. If we're going to write this in interval notation, the far left is going to be 7, and the far right is positive infinity. Infinity always gets a parentheses, and in this case, the 7 gets a parentheses. So this should be the domain of this function. Too thick. Yeah, so let's go with that. Let's hop back over to Pearson. So now it says type your answer in interval notation. So we did that, and our claim is that the domain, we got double parentheses. We said from 7 to infinity, INF. Do we agree? Disagree? We good to go? Okay. Let's go with it. Yeah, we got to check, so that means we got it. All right, so we're going to open up the mini game again. All right, so again, one day, where's my money? Uh-oh. Your money comes in the form of me offering my time here to be here, okay? And potential extra credit. Because if you get extra credit, it can boost your scores in your grade. You get good grades, you can stand a chance of making a lot more money further down the road. So I know it's a little bit of delayed gratification, but let's open up the polls, all right? Let's open up and see what might Google choose next. For some reason, I don't know why I can't get it up. Now, I accidentally typed, I totally was going to type 13, but 14 came out, so I'm going to go with it. All right, let's keep it open for about 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, and the polls are closed. All right, let's see. Let's see how we did. Okay, I started with 14. Let's see. Hey, Google, give me a random number 1 through 21.
Sorry, I can't do that yet.
Yes, you can. Give me those sass. Watch the sass, Captain Sassy Friends. Hey, Google, give me a random number 1 through 21.
Here's a random number, 20.
20. Ah, Jamar Alexander in the house. He got it. Congratulations, Mr. Alexander. Okay. So 20. All right. So let's see. Question number 20. I feel like we should have aliases because we're streaming live, but it's okay. All right. Man. All right. My number's going to come one day. My intuition's going to hit. Let's see. Can we make this bigger? What if I do like this? That kind of worked, but I didn't like that. Okay, let's go with this. So it says the perimeter P of a square tile. This is question number 20, and it comes from 1, 3. So I'm actually taking notes as if I were doing the homework, right? Which I am doing, but you know, it's okay. So question number 20, and this comes from section 1361. So it says the perimeter P of x of a square tile is a function of the length x of the side of the square. Write a function rule for the perimeter of the square tile. Find and interpret P of 6. Okay, so then they want us to do P of 6. So it says the perimeter of a square tile. So what's the basic shape that we're working with here? What's the basic shape?
Where?
A square, right? So the basic shape is a square. So it's probably a good idea to start with the square. It says the perimeter of the square tile is a function of the length x of a side. So one of the sides, we're going to call it x, right? And this is going to take us from here to here. I know you can't see what I'm writing just yet. We don't need all that. Okay, so this doesn't seem too bad, right? First they want us to write a function for the perimeter, right? If x is the length of one side, what does perimeter mean? How do we find the perimeter of a shape?
The total distance of outside.
So say all the sides are x here, right? Because it's a square. So all the sides have a length x. Tell me about the perimeter. What are we going to do?
Add them together.
Add them all up, right?
X.
So if we say x plus x plus x plus x, what's another way to articulate that more short?
4x.
4x, right? A number added to itself 4 times is the same as 4 times that number. Okay? So this will be our expression for the perimeter. Then the x is to go and find P of 6. So then it's just going to be 4 times 6, 24. Let's write that a little bit better. 24. What are the units? Let's hop back over to Pearson. Perimeter of a square tile is a function of the length. It didn't give us any units. So, but anyway, 24 units, whatever the units are. Inches, centimeters, whatever the units are. Okay, so then let's give it a go. I feel like we're ready. We're going to go 4x for this one. Cross our fingers. Awesome sauce. And then P of 6. Is there a quick way to get there? Almost there. Okay, P of 6 is 24. All right, let's open the polls. Is that it? No, wait. What does this value mean? Is it A or is it B? What do you think? Is it A or is it B? A says the perimeter of a square with sides of length 6 is equal to this value, or the lengths of the side of a square whose perimeter is 6 are equal to this value. Is this A or B?
I think it's B.
B. Let's read it again. Let me see. So what does this value mean? This 24, right? It says the perimeter of a square with sides of length 6 is equal to this value, or part B says the lengths of the side of a square whose perimeter is 6 are equal to this value.
It's A.
It's A, right? Because the
perimeter is 24.
Right, the perimeter is 24. Right? They want us to, when the side was 6, we got a perimeter of 24. I'm going to go with A.
Yeah, I have to reread the.
Yeah, you gotta read it a few times. I go to the same thing. All right, this looks good. Okay, let's open the polls. What number do you think? Let's open. I'm gonna go. Let me see what else here. What time is it? I'm gonna go. I saw a 3. We don't have 23, so I'm gonna go 3. Okay. Let's see. 10, 9, 8, 7, 6, 5, 4. Okay, and let's close the polls. Okay. Oh, just outside. Okay, I put 3. Where's the open again? Right there. Okay, let's see how do we do. Hey, Google, give me a random number 1 through 27. Sorry.
23.
Daggone it! Oh my goodness, I would have gotten that one right. I told you I saw 23 and I wanted to do 23, but we only go through 21. So I'm actually going to do this mod 21. I think I'm doing that right. Anyway, it's two left over, so I'm just going to do 2. Okay, a little bit of modular arithmetic. It might be a little bit off. I can't think right now because it should include 0, but maybe not. But anyway, forget about all that. We're just going to do number 2 for right now. Okay. Determine the domain and range of the relation and state whether the given relation is a function. Anybody want to tell me the domain here? Am I going to have to pick on somebody?
-3 to 3.
What's the domain? So the domain are a set of input values. What are our inputs here?
The Y.
Those are the outputs.
The X
So the X values are our input values, right? So it should be -3, -1, 0, 1, 2, 3. Do we have any repeating X's?
No.
Do we have any repeating Y's?
Yes.
Is that okay for a function?
Yes.
No. But yeah.
Oh, getting people. I'm getting people. Got them, coach. This is okay. Remember, the only time it's not okay, if we have repeating X's, then it's not a function. It's okay for the Y's to repeat. But if the X's repeat, then it's not a function. All right, let's see how we're doing. We're going to hit enter. Okay, let's go on to the next part. What's the range? So if the X's are the domain, which are a set of inputs, what's going to be our range here?
5, -5, 4, -1, -1, 5.
I heard -1, -1, 5. Does everybody agree before I submit this, or are there some augmentations we should do?
No, only one -1.
What happened?
Only put a single -1.
Yeah, we don't want to do the repeats, right? I think we got a double 5 and a double -1, so let's remove the repeats. And I feel like this is a little bit better. Let's go with this. Okay, going once. Awesome sauce. I don't know about you guys, but I feel some way. When I get these questions wrong, it'd be like hurting my heart. I'd be like, wait a minute. It shouldn't be wrong. So I was like, wait a minute. Let's go back. So I'd be a little nervous every time I go to hit enter. I'm like, because if I get that little red thing, I'm like, wait a minute. We're going to fight. It's either me or you, machine. It's me or you. One of us is going to be right. Okay, or we're both going to be right. But I'm not going to be wrong in either case. Okay. All right, so is this a function, yes or no? Is it a function, yes or no?
Yes.
Anybody want to say no? It's okay. All right, I couldn't bait anybody that time. Let's go with yes, right? We didn't, no repeating X's, so we should be in the clear. Okay, let's open the polls. Open. Let me see. What time is it? I'm going to try the time again. Okay, when I looked at it, I saw 14 this time. So I'm going to go 14. Okay, let's open it for 10 seconds. 8, 7, 6, 5, 4, 3. Let's type closed, and the polls are closed. 8.5. I like that answer. Too bad that's not going to be one of our choices. If it is, I'll max out your extra credit. If 8.5 is one of the answers, I will max out your extra credit. Hey, Google, give me a random number 1 through 21.
11.
11. Anybody choose 11? I chose 14. No 11s. Okay. That's okay. No winners this time. We did 11, so we're going to go to the next one, which is 12. Is this a preview? This is just a preview. Okay. So it says find a domain. Okay. Can someone explain to me, in general, for a rational function, what's the general domain for a rational function? Or can anybody tell me the domain in general for a rational function? Okay.
Infinity and negative infinity and infinity.
So say we didn't see the polynomials. All right. I might be getting a little bit ahead of myself with this next part because I haven't set it up yet. But if I were offering extra credit, I would offer extra credit to this. Can anybody explain to me, how do we find, in general, the domain of a rational function? And so usually where I do extra credit would be like 10% of your grade. You're going to earn at most 10% of your grade. So like if you somehow max out your extra credit by the end of the semester, you potentially could be boosted by 10%. But I haven't really been doing extra credit this go around. I've just been trying to keep it light. I've been doing extra credit in the form of unlimited attempts at our homework assignments. That's really how I've been doing extra credit this day. So I feel like that's enough, right? If you get unlimited attempts, it's more than enough. Okay, so the points for this will be off the table. But to find the domain of a rational function, in general, the domain is all reals except any x that makes the denominator 0, right? So in general, for something like this, the domain would be all reals except any x that makes the denominator 0. So the next train of thought is, how do we find the x's that make the denominator 0? What should we do? What would Jesus
divide?
Not divide. What? So let me see. This is question number 12, and it comes from section 1.3, question 29 from our text, right? It says find the domain. Let me get a copy of the original. We got this f of x. We got x squared plus 2x minus 3 under x plus 1, right? And this is equal. Let's move this like here. Okay. So to find the x's that make the denominator 0, let's hop over to the iPad here. So to find the x's that make the denominator 0, all we do is set the denominator equal to 0 and solve, right? Once we do that, the x's that'll make the denominator, the x's that will make the denominator 0 will reveal themselves, right? So let's set the denominator to 0. So then we get this x squared plus 2x minus 3 equals 0. Let me line up my equal signs just to be consistent and neat. So I've had students in the past, they would do kind of like this, draw a bar. So they know that, okay, this is my equal sign. I just liked it. It worked for me. So I borrowed that one from the students. Okay. Can anybody tell me, what is this technique called that I'm doing? What is this called?
Solving.
Factoring.
Factor, right? We're factoring. So we're looking, can somebody walk me through this factoring?
So you're going to look at which two numbers multiply to 3 and give you the 2. Okay. So it's going to be a plus and, let's see, 3. I know, someone help me out here.
It's okay. Okay, look. So this is actually good. This is good, right?
I think it's
Okay. I was going to say, wouldn't it be a positive 3 and a negative 1?
Okay, that sounds good, right? So this is a trinomial. We have 3 terms, right? We're factoring, hang on. We're factoring a trinomial. We're looking for 2 numbers that multiply to give us negative 3 and add to give us positive 2, right? So then, because the second sign is negative, our signs are going to be opposite signs. Okay? And then it's only 3 only has 2 factors. It's only 3 and 1. And this sign tells us that the larger number is going to be positive.
The first time?
Yeah.
Okay.
Yep. So notice that 3 times 1 is 3 times negative 1 is negative 3. 3 plus negative 1 is positive 2. So it checks out.
I have a question.
Let me finish this out and then we'll come back. Just give me just a moment because we're actually almost done. I'm going to get rid of this guy. So at this point, we're at a stage we're going to use a technique called the zero factor property. When things multiply to give us 0, long story short, we set each one equal to 0 and solve. We set each one equal to 0. That's not a minus. And solve, right? So from the first one, we get negative 3. The second one, we get 1, right? So if x is negative 3 or x is 1, if we plug those into the original, it makes the denominator 0. So we got to throw out x cannot be equal to negative 3 and 1. Those are our claims. I'm not checking these right now. But, you know, it's definitely, for instance, like, well, things are a little bit different now because if we were doing our exams in person, like if we were in person on a paper exam and we get an answer, if we don't check it, what we're saying is, oh, we got an answer. It may or may not be right, but we're going to leave it up to chance. But chance favors the prepared mind, right? So when we check, we drastically boost the odds of success in our favor. So if you're just doing pure probability, it's the chances of success are drastically boosted in our favor if we check. If we don't check, we're just leaving it up to chance, and we stand a much greater chance of getting it wrong. I'm confident in this answer. I'm going to just go ahead and plug this into Pearson. Let's hop back over to Pearson. Okay, so we're saying everything except negative 3 and 1. So should it be A, B, C, or D? A, B, C, or D? So we're saying everything except negative 3 and 1. Should it be A, B, C, or D?
D.
You said B as in boy?
No, D.
D as in doy?
D. Dog.
Oh, as in dog. Okay.
Yeah.
All right, let's go with D. Let's see what happens. So we're going to hit enter. Awesome sauce. Okay. I know there's a question. Let's hop back over to the tablet. There was a question. Did it get answered? Are you still breathing?
That was me. So when we were factoring the beginning, why didn't we add 3 and then just factor from the x squared and 2x?
Add 3. Oh. So if you add 3 to both sides, let me think about it, because I know that's what students like to do. Yeah, okay, so look. Let's do this one. Let's use this color. So, and let's kind of work here. So right here, if we have x squared plus 2x minus 3 equals 0, if we add 3 to both sides, we're going to get x squared plus 2x equals 3, right? And then if we factor, we're going to get x times x plus 2. So then we would have to find 2 numbers that multiply to give us 3. We don't have a property like this. Like we can't really break it apart. It's just going to start to disintegrate from there. But if the right-hand side were 0 and we get to something like this, then we can invoke what's called the zero factor property. Does it make sense? Because I don't really see what we can do going forward. I don't know. Yeah, there's nothing really beyond this. But yeah, so at this stage, we just factor. I don't really know how to explain it any other kind of way. Other than
Wait, I have a question.
Go ahead.
So for the answer on Pearson, why was it? I understand how we got like all the factoring and everything. Why was it D?
Okay, that's a good question. These are all good questions. Don't get that twisted. But let's look at that. I'm gonna get rid of this. I'm gonna get rid of this. Okay, so we said that our answer. We said that what x was not. We said x was not equal to negative 3 and 1, right? So say we graph this, right? If we're on a number line. And say here is negative 3 and here is 1, we want everything except this number and this number. All right, we want everything except those numbers. So, in a graphical sense, right? We're talking about all of these numbers, we're talking about all of these numbers, and we're talking about all these numbers to the right. And so we would kind of go with parentheses, kind of like that. So we want to include everything except -3 and 1. Does that make sense? Right? So then once you see this graph kind of parallels the interval notation. This answer that we got here for D. Okay. If there aren't any other questions, what's the time? Oh my goodness. We started 2:25. We go to 3:15. Is that right? No. Hang on, let me see. Hey Siri, play These Are the Times by Boyz II Men.
Just a moment.
I think.
Okay. Playing Motown Philly by Boyz II Men.
No. These Are the Times. Maybe that's not Boyz II Men. Who sings that song? Hang on, I got it. Hang on, I'm gonna try this. Hey Siri, play These Are the Times We All Wish For.
Just a moment.
It might be Casey and JoJo.
Playing This Is the Time Ballast by Nothing More.
No. Daggone it. I can't think of that song. I think it's Casey and JoJo, but I don't want to waste any more time on that. I was trying to get the song to play. These are the times we all wish for. Anyway, okay. Let's open up the polls. Again, just trying to have some fun. We only got like 10 minutes left in class. Doing a little bit of throwback, but I couldn't get it to come up. All right. So the polls are open. I'm going to go 1 because that was the first thing I saw. That was a number that I saw on the clock on the second hand. Oh, man, y'all are fast. Okay, let's do 10, 9, 8, 7, 6, 5, 4, 3. I don't know how I'm doing my fingers. I'm just totally sleepy. Let's hit close. Let's close it out. Close. Okay. Let's see how do we do. All right, let's back up right here. Hey, Google, give me a random number 1 through 21.
10.
10. Did anybody get 10? I don't think I saw 10. Oh, there it is. Tyrese Taylor in the house. Okay. Tyrese got that one correct. Let's look at number 10. His intuition was keen. Keen intuition. Okay. Find the domain of the function. See, for something like this, I would offer extra credit to the first person that give. I'm not necessarily doing that right now, but I wanna just open the floor. Can you tell me the correct answer here? Okay. First person that give me the correct answer. Normally I would give extra credit for this. We're just having some fun right now. So I'm not gonna say anything other than fill the air as best I can. But I'm just curious to see who can give me the correct answer first. And I'm taking notes. Okay. I know I'm not doing extra credit, but So now you've had a little bit of time to think about it. I'm monitoring the chat and I'm listening for the audio. So here's the first hint: with rational functions, what's the main stipulation? We can't do what with rational functions? We cannot do what?
Make it negative.
No, that's the radical. That's square root, right? We can't take the square root of a negative. But what about with the fractions? When it comes to a fraction,
You can't have the 0 on the bottom.
we cannot divide by 0. Right? Remember this? I think from last time, I'm going to hop over here. So I'm still kind of waiting for the correct answer. So remember last time, I think we made a statement like the following. Some number divided by, let's do it like this. 0 divided by some number. I think we said that this was okay. What is this equal to? Versus some number divided by 0, that's a KO. Right? So 0 divided by some number, this is okay. So that's going to be equal to 0. But some number divided by 0, that's a KO. You want to knock that out. So that's going to be undefined. Right? So we cannot divide by 0. Okay? All right. Anybody?
So
Pardon?
never mind.
Anybody want to give this a go? Okay, I would now at this point I would, let's take a look at it. I'm going to write this down and we're going to work it out. Okay, so this is question number 10 from the homework. It comes from section 1.3, question 25. It says find the domain, right? So g of x, the bottom is x squared minus 16 under x plus 3. And let me show you what I'm writing. Okay, so I just wrote down the main points from this question. I told you I got this whole presentation down much smoother It's like you can actually see what I'm writing. I can see a few of you guys. We can see the chat. It's the first was like a learning curve. I was like, no, I think I got it now. So anyway, and then we're seamlessly flowing between the iPad and Pearson. I'm like, come on. feeling myself. Anyway, just having some fun. Just trying to bring the gaming fun energy to the whole thing. I'll keep you for no more than 5 minutes, and then we'll let everybody go. Okay. So again, for a rational function, we cannot divide by 0. So we have to throw out any x that makes the denominator 0. So all we do, again, set the denominator equal to 0, right? So the denominator in this case is x squared minus 16. Oh, I forgot to stop it for my next set of students. Go ahead and close. Let's enable the waiting room, and let's lock the meeting. I know I had someone just come in, but it's okay. They can listen in. We'll be back. It's not a big deal. But I meant to do that. I just got to remember that. Okay, and we're going to set this equal to 0, right? I would offer extra credit for this next question. Can somebody factor this for me? So again, or there's actually, now this one you can do the other way. There's a couple of ways to do this one. The easier way would be that, but I don't want you to get in that habit. So I'm going to factor this first, and I'll show you the alternate way that parallels what I think you guys might want to do. So this is actually a special factoring. We have a squared minus b squared. We have something squared minus something else squared. So this is actually a special factoring, and it factors into 4, right? Like this. This is a special factoring scenario. Okay? If you're not comfortable factoring, I actually have handouts on all the factoring scenarios that we'll come across. When I first started teaching, I scanned this chapter that was on all the factoring scenarios that we'll come across for this course. You actually have access to it if you go to your box folder. Let's hop over to it and pull it up now. Did I close it? I think I minimized it. I'm going to try to pull it from, let me see if it'll, not there. Let me minimize this. Let me see, come on. Let's go to, he didn't leave on purpose. There's no words. It can't be 4 negative 4. I'm gonna do this later. But yeah, if you want to see a chapter entirely on factoring, just let me know, and I can point you to how to access those files. But you actually do have access to it right now. Let's hop back over to the iPad. Okay. So yeah, long story short, set each one is equal to 0 and solve. Ultimately, you get x equals plus or minus 4. But again, from the original, we had to throw those results out. So x is not equal to plus or minus 4. So then it's the same kind of argument as the last example. The domain is going to be from negative infinity up to negative 4. Union of negative 4 to 4. Union 4 to infinity. Okay. So this should be it. It's the same kind of argument as the one where we drew out the graphs. It's the same one as the one before. Come on. Thank you. And let's go style. So, hang on. Let me check it in Pearson really quickly. Type your answer in interval notation, parentheses, negative INF, comma to negative 4. And then the next one is cup. That's the right symbol. Parentheses, interval notation, negative 4 to 4, negative 4, comma 4, backslash cup. And then we want 4 to infinity, 4, comma INF. Okay, let's cross our fingers. So come on, thank you. Okay, so there was a question coming in. Let's entertain the question. Did it get answered?
No, I was saying, like, how did you, like, set it up that way? And I really don't know what union means. I forgot.
So union just means, basically, we're saying this interval combined with this one, combined with this one. So okay. Even though they don't overlap, we're saying, basically, you can pull an answer from here, or here, or here. Right? And so in this context, the U kind of like acts like an or. You know, something like that. So, but basically...
just like showed on a number line?
Yeah. Yeah. Okay. Oh, you want to see it on a number line?
Yeah, sure. Yeah, sure.
What was your first question? Let's go back to that one really quick.
You answered it.
Oh, okay. Did you still want to see it on the number line?
Yes, sir.
Okay. So on the number line, right? So let's see. So it's here. That's the positive x direction. So like here's -4, here's 4, right? So basically, if we're saying x is not equal to plus or minus 4, we want everything except these two numbers, right? So then that means we want all of these numbers going this way. We want all the numbers in between these two, and we want all these numbers going to the right. So then we would group these with parentheses, like that. So basically, we're saying everything except -4 and 4.
Okay.
Wait.
Excuse me, Mr. Piper.
Yes.
So if it's up, it means and if it's down, it means or, right? Or is it switch?
You got it reversed.
It's reversed? Okay, so
Yeah.
if it's up, it's or. If it's down, it's and.
This is or. These mean or.
Wait.
Okay.
You talking about the union?
Yeah, union means
Yeah.
or. Yeah. It basically just means put them together. Where and there's another symbol that comes. It's called and. It means intersection. It'll look like this, and basically it's saying where do these sets overlap? Or in other words, what do they have in common? This is called intersection. Intersection. And this other symbol, these symbols are called union. These are called union.
Okay, it makes sense now.
Yeah, it's no worries. Okay, guys, are there any other questions for the group? If there aren't any other burning questions, I'm going to go ahead and load a copy of these notes. Hopefully I labeled it already. Yeah, let me go ahead and label it. But I'll load a copy of these notes in our box folder on Blackboard. Let me go ahead and do this now. So let me see. This is week 3, section 1.3 homework session. This is for college algebra. We meet Tuesdays and Thursdays, 2:25 until 3:15, and this is 3:15, and this is fall 2020. 2020 has been a hell of a year, man. This has definitely been the worst year of my life. But it's okay. It's all part of life. We keep it moving. We accept these things and we kind of keep moving. Okay, but it's that's life. Let me get back to a blank page. Okay, guys, I didn't want to keep you any further. I'll let everyone go. I do intend to stream my sessions with my other classes. So if you ever wanted to sit in on one of those sessions, you're more than welcome, or you can watch it on the stream, or however you want to do that, really. Okay, guys. Otherwise, have a great weekend, and I will see you all same place, same time, same location on this upcoming Tuesday. Take care. Deuces up.
Your office hours are only on Wednesdays, right?
Huh? Office hours, yeah. But just email me and we can schedule another time if we need to.
Okay.
Professor Pfeiffer.
Go ahead.
I had a question. I apologize. I was having internet troubles. I couldn't get in. I was trying to get in when it first started, but it booted me.
Oh, who's this?
And I was London Jones. It's still not letting me connect. Every time I try to connect my face, it like boots me. I don't know.
Okay, it's fine. Let me just update my attendance. Let me go here.
Yeah, because I was thinking it was like because I've been to every class. I don't think you got me for attendance. I'll be quiet. I don't really speak that much.
Wait, you can't. You gotta make your presence known much sooner. Okay.
This is college algebra 1, right?
Yeah.
The Pearson. That was another thing. The Pearson. I'm on it right now, but I don't see any listings for anything. Like it just keeps saying it will open in another page, but it never does.
Okay, let me see. Hang on. Let me make sure. Let me check something. Let me check. Let's go here. Come on. Let me check here. This one. So I can mark you as late today, but yeah, because we take a few passes through the attendance. Okay, so it usually takes like about 15 minutes for us to get through the attendance. So
yeah, I think this is the only one I've missed like most of. I'm usually here at the beginning.
Okay.
For it.
So yeah, just make sure.
Yeah,
make sure to get your presence known. I can't make a note, but it's okay. But I'm marking as late today. Okay. Okay. Anybody else need anything? We're okay. Okay, guys. I'll see you Tuesday. Take care. We can stop the share. Let me see. I don't know if that works or not. So let me just do what I know works. Let me see if it works.